So moving on from energy to work and power, we've got a situation. A roof tiler uses a conveyor belt to lift bundles of roof tiles from the ground to a roof 3.2 meters high. Each tile has a mass of 3.1 kilograms and they come in bundles of 7. So again, I'm going to draw a little diagram. Here's my wall and roof. Here's my conveyor belt to the ground. Here's my bundles of roof tiles moving up the conveyor belt. Okay. I know that the height that I need to worry about here is 3.2 meters. I know that each tile is 3.1 and they come in bundles of 7. So each bundle is 3.1 times 7, which, if my maths is right, is 21.7 kilograms per bundle. So what we want to know first at step 1 is, alright, so we have H equals 3.2 meters. We have M, let's just use the whole bundles, 21.7 kilograms per bundle. Let's use, well, we know G equals 9.8. I've been using 9.8 rather than 9.81 or 9.82 for simplicity here. We can decide, because actually it turns out that the gravitational force near the surface of the Earth is either one or the other depending where you are, but 9.8 is quite adequate for our purposes usually. So they're going from the ground to the top. We won't worry too much about the detail. So how much work, first question is how much work is done on each bundle of tiles. Well, remember, the work is the change in energy. So we've changed their gravitational potential energy. We've arbitrarily chosen the Earth as the 0 point of gravitational potential energy and the roof as 3.2 meters above that. So the amount of change in their gravitational potential energy, EP equals mgh. We could even write it as mg delta h, because the mass is the same, the gravitational acceleration is the same. What's changed is the height, and the height is changed by 3.2 meters. That's the difference in the height. So equals 21.7 times 9.8 times 3.2 equals 680.5. Sorry, started heading off in the wrong direction around an 8. 680.5 joules per bundle. We could divide that by 7 to get per tile, but we were asked for per bundle. So 680.5 joules per bundle. And that's basically the answer to that question. Now, the conveyor belt can lift 22 bundles per hour. So what is its effective power? Now, I said effective power there because there's lots of waste energy. It could be heating up the belt or the bearings. It could be doing lots of things. So, it might be a 3 horsepower motor that's not putting out anywhere near 3 horsepower in terms of effective energy. So we just are interested in the work we can actually get, not the work theoretically possible. So what's its power? So its power equals work per unit time. Now, how much work is it doing every hour? It's doing this much, 680.5, times 22, because it's doing 22 bundles per hour, times 22. So that's the total amount of work it's doing each hour. It's doing 680.5 on each bundle, and it's doing 22 bundles. The time is, we've been given 1 hour, but we need seconds because we need the correct SI unit. So 60 times 60 is 3,600 seconds. 60 seconds in a minute, 60 minutes an hour, 3,600, which gives us 4.16 watts as the power. Now, I happen to know that a kilowatt, 1,000 watts, is about, now which way does it go? A kilowatt is about 0.75 of a horsepower. So this is not a massively powerful motor, but it doesn't need to be. If it's getting the tiles where they need to be, we don't need a V8 on the conveyor belt. So 4.16 watts is the power, the effective power of this motor.